Here, this is a video lesson on limits, an example. I'm going to draw a piecewise function very clearly on a graph, and we're going to use it to ask many limit questions. I'm going to skip to make space and label this 2. I have 1 here and an open dot at the coordinate 1, 2. Also going to have an open dot at the coordinate 1, 3. This is going to be a transition between a curving piece of the piecewise function and a linear piece that will also have an open dot at 3, 2. We'll call this function f, and we're going to ask several questions about this graph. What is the function, the value of the function at 1? What is the limit as x approaches 1 from the left of this function? What is the limit as x approaches 1 from the right of this function? And what is the limit as x approaches 1 of this function? We'll ask a few more questions, but let's get some answers to these first. The first is a typical question in algebra. If we put 1 into this function, then what value does this graph represent? We take a look at 1, we see an open dot. An open dot is a placeholder. It suggests that to the side, it's approaching this point, but there is no value at the open dot. And we have a second open dot here, and there's no filled in dot, so we do not have a value of this function at 1. The 1 is an important place. There's no value. We could say no value, or DNE for does not exist. The function is not defined at 1. What about the limit as x approaches 1 from the left? In our approach statement, the number that is being approached has a superscripted minus here, which means that we have to, this is a limit question, we have to imagine that we are on the function line and we are going towards 1 in the domain, coming to 1 from the left. So where do we think that we're going to be if we follow the trend of the function? We ignore the fact that once we get to 1, there's no value. This is a limit question, so we think that we're going to end up at 2, even though there's no value there. The limit, the answer to this limit question is 2. So we have to keep in mind that limit questions and limit statements are a different concept and often have different answers than value questions and value concepts. Let's do this again. This time we're going to approach 1 in the domain from the right. So we have to imagine that we are on the function and we're following a trend and we're observing and thinking, if I follow this trend, where do I think I'm going to end up, or how high do I think I'm going to be? What is my vertical position when my horizontal position gets to 1? And I think that I'm going to be at 3. Even though there's no value there, the answer to this limit question, which is a one-sided limit question, is 3. So let's take these together. We could ask the limit question that is not one-sided, so we call it an absolute limit. What is the limit as x approaches 1 of this function? Well, we think that we're going to different places from either side. And because it does not, the one-sided limits do not approach the same value, the answer to these two questions from the left and from the right are different limits, 2 and 3, then there is no absolute limit. So we could say it does not exist, or no limit. And we're reminded that if we are going to have an absolute limit, one that does not approach from a single side, then the one-sided limits have to be equal. And we can write a statement. if x approaches any value in the domain, we'll say a, from the left, and it is equal to the limit as x approaches that same value a from the right. So this is the one-sided limit statements. And if they're equal, then we can say that the limit as x approaches a, the absolute limit, exists. One-sided limits have to be equal for the absolute limit to exist. Let's ask a few more questions of this function. What is the value of the function at 3? What is the limit as x approaches 3 from the right? What is the limit as x approaches 3 from the left? And then two limits of different nature. What is the limit as x approaches infinity? And what is the limit as x approaches negative infinity? Let's answer these questions. What is the value of the function at 3? Again, there's an open dot, suggesting a placeholder but not a value. I can't observe any other value at 3, so we say it does not exist. The function is not defined at 3. What's the limit as x approaches 3 from the right? We're approaching 3 in the domain. We can imagine that we're on the function to the right of 3, and if we follow the function's trend, where do we think we're going to end up? At 2. The limit of the function as we approach 3 from the left, if we follow this trend, we think that we're going to end up at a height of 2. The one-sided limits exist at 3. They're both 2, and they're equal. So we can say that the limit as x approaches 3 of this function exists and is also equal to the one-sided limits. So in this case, the function has left and right limits and an absolute limit, and they're all equal, and they're equal to 2, but there is no value of the function at 3. Limit statements are different than value statements. And finally, what is the limit as x approaches infinity? Well, we have to imagine that we could see the graph continuing and observe where this function is going. And the way this is drawn, it seems to suggest that this is a linear piece. We can't prove it because we don't have the equation for this function. But we can assume that if this is a very straight line, then it's going to continue that trend down to negative infinity. So the limit as x approaches infinity is equal to negative infinity. And likewise, and this is a little more clear, as x approaches negative infinity, if we could see this part of the graph go on and on and on, then the values of the functions are definitely going down. The arrow curves and plummets down with an arrowhead to say it continues that trend towards negative infinity. We have absolute limit, one-sided limits. These are called infinite limits because their approach statement includes infinity. And there's two ways to approach infinity, to the right or to the left, going in the positive direction or in the negative direction. And when we analyze the infinite limits in those two directions, we're talking about the end behavior of the function. If you are asked to comment on the end behavior of a function, you would be looking to the infinite limits, to the positive infinity and negative infinity.